So you've probably been hearing the term RAG everywhere, right? If you've been wondering what it is and what all the hype's about, well, you've come to the right place. We're going to do a complete no-fluff breakdown of what Retrieval-Augmented Generation actually is, why so many people get it wrong, what's really going on under the hood, and then we'll get into the 10 patterns you absolutely need to know.
All right, let's just dive right in with a simple analogy that really makes it all click. Think of RAG as an open book exam. You see, a standard large language model, an LLM, is kind of like a brilliant student taking a closed book test. It only knows what it memorized during training, so its knowledge has this hard cutoff date. RAG, on the other hand, gives the AI a whole stack of textbooks and notes it can look through before answering. It gets to access external, up-to-date info to find the actual relevant facts.
And this is the crucial point here. RAG, or Retrieval-Augmented Generation, isn't just one single thing. It's an architectural pattern. It's a system that combines a retrieval component, which is like a specialized search engine for your private data, with a generation component, which is the LLM. This partnership is what fixes the LLM's biggest problems, because it gives it the power to look things up first. This ensures its answers are grounded in real, retrieved context, instead of being, just made up.
So here's our game plan for today. We'll quickly cover what RAG is, bust 2 huge myths, take a look at how it all works, then dive into the 10 essential patterns, and we'll wrap up by looking at where all this is headed. Okay, let's get into it by first tackling 2 massive misconceptions I see floating around all the time. And honestly, they're really holding people back from understanding how to build AI systems that, actually work.
I hear 2 arguments constantly. First, that RAG is dead because of its early flaws. And second, that new tech with these giant memory capacities just makes it totally unnecessary. Let's break down exactly why both of those ideas are wrong.
First off, this idea that RAG is dead, it's just plain wrong. Yeah, some early research showed that LLMs could still hallucinate even when they had retrieved information, and a lot of people jumped to the conclusion that, see, RAG is broken. But here's the thing. RAG isn't a single technology. It's an evolving architectural pattern. The newer, more advanced patterns we're about to talk about, they were built specifically to solve those early problems. RAG isn't dying, it's just getting started.
The other myth is this idea that you can just forget about retrieval systems if you can stuff a million tokens, which are basically just pieces of words, into a prompt. I mean, it sounds logical, doesn't it? Just give the model everything it could possibly need. But in the real world, this brute force approach just falls flat on its face. And this slide right here tells the whole story. Let's compare them directly. The brute force approach, just jamming a massive context window full of data, is astronomically expensive at scale. I mean, every single query costs a fortune to process. It's also incredibly slow. But here's the real kicker. Research shows it's actually less accurate. The model literally loses the signal in the noise. The right answer gets buried in tons of irrelevant junk. A smart RAG system, on the other hand, is efficient, fast, and way more precise.
Okay, let's head down to the engine room and see how this thing is actually built, because understanding these core components is what separates systems that really work from the ones that are just, fancy, expensive demos.
So, at its heart, a RAG system has 3 basic steps. First, you have ingestion and chunking. That's where you break down your documents. Second is creating embeddings, which turns that text into numbers a computer can work with. And third, you store those numbers in a special vector database, so you can search them super fast. Now, how you break up or chunk your documents. This is absolutely critical. Naive chunking just chops documents into fixed-size pieces, which, you guessed it, often cuts sentences right in half and destroys the context. A much smarter way to do it is with semantic chunking, which breaks up the text based on natural topic shifts. Or you could use hierarchical chunking, which can retrieve a tiny, precise chunk, but then pass the whole larger parent section to the LLM for better context. It's way more effective. Okay, next up are embedding models. Models like OpenAI's Text Embedding 3 Large or Voyage AI's Voyage 2 are what turn those text chunks into meaningful numerical vectors. Then you've got vector databases. Think of services like Pinecone or Weaviate that store all these vectors and let you perform incredibly fast semantic searches. And we're not just talking basic search here. Modern systems use hybrid search, which combines that semantic, meaning-based search with good old-fashioned keyword matching to get the best of both worlds.
And now for the best part, the playbook. These are the 10 different RAG patterns you need to know. Each one solves a different, real-world problem, and together they really show the evolution of this whole architecture.
Think of these not as just minor tweaks, but as 10 totally distinct architectures. They build on each other, moving from super simple prototypes to incredibly sophisticated, self-correcting systems. So we start with the basics. Pattern 1 is simple RAG. It's the hello world of the field. You retrieve some info, stuff it into a prompt, and get an answer. It's great for our prototype, but that's about it. Pattern 2 adds a memory layer, which helps with conversational context. Number 3 is branched RAG, which cleverly breaks down a complex question into smaller sub-questions to get more accurate results. And number 4 is hide, which uses this brilliant trick. It generates a hypothetical answer first, and then it searches for documents that look like that answer. It sounds weird, but it dramatically improves search quality.
Now things start getting really intelligent. Pattern 5, adaptive RAG, adds a smart routing layer that decides if a simple question like what's 2 plus 2 even needs a database search, which saves a ton of time and money. Number 6, corrective RAG, adds a quality gate. It actually evaluates the documents it finds, and if they're no good, it can rewrite the query or even go out and perform a web search. Then there's number 7, self-RAG. This is where the LLM itself generates these little reflection tokens to critique its own reasoning as it goes, checking if its claims are actually backed up by the sources.
Okay, now, Pattern 8, agentic RAG, is a genuine game changer. This is where the entire field is heading, and for a very good reason. It combines RAG with what are called AI agents.
So instead of a simple one-shot process, the LLM in an agentic RAG system acts more like an orchestrator. It analyzes the task and then decides, in a loop, what to do next. Should it search the database, call an API, maybe run some code? It keeps looping and evaluating its own progress until it finds a good enough answer. This is absolutely transformative for handling complex, multi-step problems. And finally, we have patterns that tackle the complexity of real-world data. Number 9, multimodal RAG. Goes beyond just text to handle charts, tables, and images by using vision models to describe what's in them. And number 10 is graph RAG. This builds a knowledge graph to explicitly map out all the entities and relationships in your data. For questions that require connecting the dots between many different documents, this thing dramatically outperforms standard search.
So after seeing all 10 of these really powerful patterns, what's the big takeaway here? What's the crucial point?
And this quote just illustrates the main idea perfectly. RAG isn't some static tool that's either dead or alive. It is a flexible design philosophy, a way of building intelligent systems that just keeps improving and adapting to solve harder and harder problems.
And if you look at where the innovation is happening, the future is clearly all about more intelligent, more connected, and more multifaceted systems. Agentic RAG, which lets the system reason and use tools, and Graph RAG, which understands the deep relationships in data, they're the ones leading the charge.
And remember, this isn't some niche academic trick. This is it. RAG is the foundational architecture for nearly every serious enterprise AI application being built today, from customer support bots that actually help people to systems that can do complex legal document analysis.
So that covers the architecture and the 10 patterns that are shaping the future. And it leaves us with one last provocative thought to chew on. Now that AI has an open book, what are the truly interesting questions we're going to ask it to find? Thanks for tuning in.